Hi, good evening, everyone. Today we are going to discuss about problems on Thevenin's theorem, especially on dependent sources. These problems are very much important when you are solving the competitive exams or gate problems or competitive exams. Just try to understand. This is very simple if you understood the logic. So we need to find out the Thevenin's equivalent. The question is asked, find the Thevenin's equivalent across AB terminal. So already you know that the Thevenin's equivalent will be consisting of an voltage source VOC, and you are going to have a Thevenin's resistance. So this is a Thevenin's equivalent, and here you are going to have the load resistance. So first you have to find out open circuit voltage, and second you need to find out the Thevenin's resistance. Okay, so this is what we have to find out. So in order to find out, let's try to take this problem. So first step, let us try to find out the open circuit voltage. So I'm going to redraw the network and I'm going to find out the open circuit voltage. See here, so this is the RL given to us. So how to find out RL is remove the RL. Okay, so remove the value of RL. So when you remove this RL, so you're going to have the network like this. This is an 1 ohm, this is an 1 ohm, and this is nothing but a source given to us. Let's try to discuss about that source also. So this is the network given to us. This is of 1 ohm, this is of 1 ohm, and this is positive negative I1. So this is of again 1 ohm. So I have been removed it. If I make it open, okay, and the current given in this branch is I1. So now these two terminals are open. When they are open, automatically current will become 0, and in an open circuit what will be available? Voltage will be available. That voltage is called open circuit voltage. So now the current is flowing like this. You see here, this is written as 2 into I1. So what is this 2 into I1? 2 times I1, where I1 is called dependent. And what kind of source this is given? Positive and polarity, positive polarity and negative polarity is given. This is called as a voltage source. So I'm going to call this as a current dependent. What is the polarities are there? Voltage source. So this is called current dependent voltage source. So now we need to find out. See here, uh, so that's why these problems are called dependent problems. Okay. So for this problem, you can see here the input is open circuited. Automatically I1 will become 0. So when I1 is 0, so here you can understand the drop across this concept. Okay, so the drop across this. Okay, so when you write down the drop across this, V is equal to, what is the I value? I is 0 into what is the R value? 1. Automatically the voltage will become as 0. If the voltage is 0, these two are shorted. Okay, so the voltage is 0, these two are shorted, and this VOC will be available here, which is nothing but VOC. This is positive VOC and this is negative VOC. That's how this node voltage and this node voltage are same. So now let's try to find this VOC. So how to find this VOC? Let's try to mark some two currents are there. I'm marking this is I'm going to apply nodal analysis, and I'm assuming that this node voltage is of high potential and current in this branch is Ix, current in this branch is Iy. So when you see this, so apply nodal analysis at which node? VOC node. How many entering currents are there? There is no entering currents or leaving currents. Okay, so there is no entering current. The leaving currents are, one is Ix and next one is Iy. So that is equal to, so how to write down this current Ix? So I can write down this as VOC, and current is leaving. This is also voltage source, minus 2 into I1 divided by R. What is the distance of this branch? 1 ohm. Okay, this is the current I am writing. Next, I want to write down the current Iy. So how to write down the current Iy? So Iy is equal to current is leaving, or the leaving polarity plus VOC. VOC minus 0 divided by 1. So when you see here, already it's very clear that since it is open circuit, I1 will become as 0 and this term will become as 0. So automatically whenever it is 0, this 0 is equal to VOC plus VOC, which is equal to 2 VOC. Therefore, VOC is equal to 0 volts. Okay, now successfully we find out the open circuit voltage, which is 0 volts. So second step is all about finding out the Thevenin's equivalent. Okay, so try to see here how to write down the Thevenin's equivalent. So we have to remove the load resistor. I have been removed the load resistor and I am drawing the network. Okay, so when I draw this network, we can have a source like this. This is of 1 ohm, this is of 1 ohm, this is positive, negative, this is 2 into I1, this is 1 ohm. So for the problems like this, I already told this is an problem only on dependent source. So when you have a only problem on a dependent source, how to find out is first you apply some DC voltage across the removed load resistor and find out that and express this in the form of VDC by IDC. So this is the procedure of finding out R Thevenin. So I have been removed the load resistor and I'm going to apply some voltage, so which is nothing but this voltage. Okay, so I'm going to apply some voltage. So I'm going to apply some voltage here, which is nothing but VDC. So, and I'm using that already in the problem. What is given? I1 is given. So now we need to find out R Thevenin. So how to find out R Thevenin? So we have to find out R Thevenin is like this. R Thevenin is equal to, I have to express in the ratio of VDC by I1. So VDC by I1 I have to express. So try to find out the equations. Okay. Every equation should be only of VDC and I1. So here you can see here, this is an what is the voltage at this node, which is VDC. This will create a new unknown node which is called as Vx. Okay, now let us try to mark the currents which are flowing into this branch. I1 is entering and I am assuming that when I am applying the nodal analysis, I am assuming this node is of higher potential, so the current will be flowing in this branch. I am marking this current as some Ix and I am marking the current in this branch as some Iy. So when you apply the nodal analysis, how many entering currents are there? So no entering currents is I1 is entering. So in order to find out, we are going to apply nodal analysis with respect to Vx node. With respect to Vx node, what is entering current? I1 is the entering current. The leaving currents are Ix. So this is one leaving current, this is Iy. Now how to write down I1? So I can write down I1 as, so I want to write down this current I1. So what is the voltage at this point? Current is leaving, which is VDC, and current is leaving here. What is the leaving polarity? This is positive and this negative. What is the leaving polarity? Minus Vx divided by 1 is equal to, how to write down this Ix? So Ix I can write down it as Vx minus 2 into I1 divided by 1 plus Iy. How to write down the Iy? So I can write down it as Vx minus 0 by 1. So see that the complete equation should have only the values of VDC. Okay, so now let us try to solve this problem. So here we have VDC. So the unknowns we have is only Vx. So we need to write down the relationship between VDC and Vx. So when you see this problem, so at this point I'm going to find out the relation. Okay. So when you see here, So here, so here when you see this equation, so here we have VDC and you have a resistance, and here we have Vx. This is plus Vx and this is minus Vx. This is plus VDC and this is minus. And here the current I1 is flowing like this. Whenever the current is flowing, this is positive terminal. Current is leaving, this is negative terminal. So I want a relationship between, I have to express the relation Vx. So I want to express Vx in terms of two quantities. One is either VDC and I1. So when you see here, so current is leaving. What is the leaving? So I want a relation between, for these three sources. I'm going to apply Kirchhoff's voltage law to link all those. So current is leaving. I'm going to write down this as VDC, and current is leaving is minus I1 into 1, and current is leaving like this. But the leaving polarity of this minus Vx. So we can write down VDC minus I1 is equal to Vx. So successfully we expressed Vx in terms of VDC and I1. So when we start solving this problem, so we are going to separate these terms, and this is 2I1. This side when it gets, so we are going to get it as VDC minus 3 into Vx. Okay, VDC minus 3 into Vx, we are going to get it as minus 2 into I1. So this is the equation we are having. From solving this, you are going to get it, and we require the value of Vx. Now you try to substitute this equation. So the resultant equation, from here we are going to solve it. So this is nothing but minus 2 into I1 is equal to VDC minus 3 into Vx can be written as VDC minus I1. So from here we are going to get minus 2 into I1, which is VDC minus 3 VDC, minus into minus is plus, which is 3 into I1. So this 3 will come this side, so it is nothing but minus 5 I1 is equal to minus 2 VDC. Resultantly these two will get cancelled, and we require the ratio of VDC. So we require the ratio VDC by I1 is nothing but 5 by 2 ohms. So successfully we had find the values of this value. Now coming to this value, so this is our equivalent circuit. Now the Thevenin's equivalent circuit we are going to get like this. So the VOC is equal to 0 volts, and so this is only the Thevenin's. So this is nothing but Thevenin's is equal to, we expressed it as an VDC by I1, where this is equal to 5 by 2 ohm. So this is what it is asked in the problem. So this solving this problem is very simple, but you have to keep it in the mind how to solve. If you want, I will revise it again. So this is the problem given. Is asked to find the Thevenin's equivalent for the network shown across which two terminals? AB terminals. So now when you, the first step is finding out open circuit voltage. Remove this voltage source. Automatic, when you remove it, the current in this branch will become 0 and the voltage drop will become 0. Automatically this node is shifted to here, and I want to find out that node voltage. So I had applied the nodal analysis, and there's no entering current. Leaving currents are Ix and Iy. So VOC minus 2I1 by 1, VOC minus 0 divided by 1. So from here I got, and already it is known, it is open circuited, I1 is 0, we got VOC. Coming to this problem, so already I told while solving this Thevenin's theorem, the Thevenin's resistance can be find out by performing one thing. So you apply some voltage and find out the current in this branch, and we are going to express this R internal as VDC by the total current, where the total current given in the problem is I1. So when you solve it, so we apply the voltage, and this is a new voltage we got, and we are going to apply the nodal analysis, and we have written I1. V1 is VDC minus Vx by 1. So how to write down this current Ix? Vx minus 2I1 by 1. How to write down Iy? Vx minus 0 by 1. If you solve it, you have got an equation, but this equation is having an unknown Vx. How to solve this Vx? Again, we want a link between Ix should be expressed in terms of VDC and I1. I read on the network, this VDC is there, this is Vx is there, and current I1 is there. This is one voltage, this is another voltage, and here you have a 1 ohm resistor. So in order to solve it, I have applied the KVL. Current is leaving plus VDC, and current is leaving minus I1 into 1 minus Vx. So now I got the value of Vx. So from this equation, I have been solved it. So this is nothing but VDC minus Vx. So that is equal to Vx minus 2I1. So you can see here, this is VDC is equal to this Vx I am sending to the side, which is nothing but minus 3 Vx. I mean VDC minus 3 Ix is equal to minus 2I1. So from this, I substituted the value of Vx. I got the value of this. This is called the equivalent circuit of Thevenin's network. Hope you are able to understand. If you feel the class is useful, please like, share, and subscribe to have more videos. And your like, share, and subscribe will help us to do more videos for the efforts what we are making. Hope the things are very clear. Yours, Ram. Thanking you for watching the video. Thank you.